This chapter, let's talk about polynomials. Now, what exactly is the definition? It says algebraic expressions which have only whole numbers as exponents of variables are called as polynomials. So we have three terms we need to understand here: algebraic expressions, exponents, and variables. And how the exponents? They're basically whole numbers. So we have four terms basically. Keep that in mind. Let's go ahead and talk about it one by one and come back to this. It's a pretty easy thing. This is not necessary to understand this in depth, but still it's nice. Okay, what exactly are algebraic expressions? All these guys, like say 2x is an expression, 4x squared plus 3x is an expression, 2y squared plus 4y plus 3, that is an algebraic expression. Even let's say you have a number 10, is that an expression? I can call it to be algebraic expression for sure, because I can write this as 10 into x power 0. So all these guys are algebraic expressions. Okay, so we understand that very clearly. Now, what is the next thing? It says which have only whole numbers as the exponents. So what exactly are exponents? So these numbers which are the powers on the variables are called as the exponents. Here the power is 1, so exponent is 1. Here it is x squared, the exponent here 2. Now if I take like something like y cubed plus 3y squared plus 2y plus 6. Now what is the power here? I can say the exponent is 3. Okay, when I say the exponents has to be whole numbers, then only they call polynomials. So can then that also be like, let's say x to the power half? Now these guys are not whole numbers. It is an exponent, but it is not a whole number. So this guy is not a polynomial. All these guys are polynomials because they are algebraic expressions, yes, and the variable is having the power as a whole number. The exponent is basically a whole number. I call that to be polynomials, and these guys are not polynomials. So I can take another example. I can write y to the power 3 by 2, yes, plus 4y plus 6. Though I have the exponent to be a whole number here, but I can see here it is not. Here the exponent is a fraction, a rational number basically. It has to be a whole number. It should be a full number. It's only then I can say they are called as polynomials. Now one more thing. We have something like variables. What exactly are variables now? Let's try to understand that. It's a small thing. Now in this case, I can say x is a variable, x is a variable. In this case, y is a variable. Now if I have another expression like say 2z squared plus 4xy plus 6. Now I can see there are three variables. X is a variable, y is a variable, z is a variable. They're all variables basically. Okay, but I can see the power here is a whole number, so this is also a polynomial, but not in one variable. You have 1, 2, 3 different variables. Okay, now I understand what exactly variables. Now let's try to understand why variables are important, how they came up. For that, your book is taking a beautiful example. It says, let's say we have a square. I need to find the perimeter of this square, and I say that it's 3 centimeters here, 3 centimeters here, 3 centimeters, and 3 centimeters. So what exactly is perimeter? It is nothing but the sum of all the sides. So 3 plus 3 plus 3 plus 3. If I write that, that is 3 plus 3 plus 3 plus 3. Okay, that makes sense. So I can write 4 times 3. Yes, that is 12. It means the sum of all the sides can be written as 4 times the length of the side. That is 12 again. That's the perimeter. Now what if my square was a little different? My square was a little big, then that's how it was. Now let's say that's 5 centimeters, 5 centimeters, 5 centimeters, and 5 centimeters. Now what is the perimeter? I can write perimeter is 5 plus 5 plus 5 plus 5, and I can write that to be 4 times 5. So understand one thing, that's a square with the length 3 centimeters, right? And that's a square whose side is basically 5 centimeters. So if I say some square, okay, some random square whose length I don't know. Now let's take another general square whose length I really don't know. So what will I call the side? What is the length of the side? Since I don't know, I'll take it as x some length. It can be 2, it can be 3, it can be 4, it can be 5, it can be 10, it can be 50. So I'm taking a variable. Now that is a variable which can take any value. So perimeter can be written as x plus x plus x plus x. Alright, and that is 4 times x or not. That is the formula I have. Now what is x here? It's a variable. Now what is the length and what is exactly x? I don't know. It can be 2, it can be 3, it can take any value basically. That exactly is called as a variable which can take different values. All right, so when I say that is a square, then x is 3 here in this case, and if this is the square, then x is 5 here. So there can be a square with x to be 10 centimeters also. That's a bigger square. So what exactly are variables? Those are those letters which I use for the values are not known. We may find this later, but that's how it works. So these are the variables. Now let's come back to the definition. Pretty easy. We know what variables. So these are letters like this, okay, which can take different values. Yes. What are algebraic expressions? All these guys are algebraic expressions which have only whole numbers as exponents. So like these are not whole numbers, so these are fractions. So these guys are not polynomials. Basically, that is a polynomial in more than one variable. There are 1, 2, 3 variables here, and I can say these are polynomials only in one variable. Here, this guy, the variable is x, and that is the power or the exponent, which is a whole number. That is the exponent, which is a whole number, and the variable is only x. So we understand, very simple guys, the definition is simple. Algebraic expressions, these guys which have only whole numbers, the power, basically the exponents are whole numbers on what? On the variables, are called polynomials. Beautiful. So let's go ahead and work on this chapter.